Let's take a look at some examples of finding exact trigonometric function values. A calculator can be used to find approximate trigonometric function values. So for example, we can find cotangent of 840 degrees by, first let me make sure I'm in degree mode, which I am, and then cotangent is the reciprocal of tangent, so a TI 83 or 84 will allow us to calculate the tangent of 840 degrees, and placing that in the denominator under 1 will give us the cotangent value. But notice that we get this decimal expression that seems to go on forever, and in fact it does. So eventually the calculator and we would have to kind of round that expression, so we could say cotangent of 840 is negative 0.577, but what we're interested in is finding an exact expression. And so exact expressions involve no rounding. And so while it is true that the calculator can be a very helpful tool and it can certainly help us check our work, in order to get an exact expression we're going to use some of the techniques that we talked about in the earlier videos relating to drawing angles in standard position. So let me start. I want to work through these 4 examples here, but let me start by reminding us of the sort of general strategy that we talked about. So as a general strategy, I can sketch the angle in standard position. For some of these problems, we won't know exactly what the angle measurement is, but we can still make a sketch that represents that angle. The second step then is to find a point on the terminal side, or actually, sorry, let me take a step back. I want to draw a reference triangle by drawing a vertical line from the terminal side of the angle to the x-axis. This creates a reference triangle. And with that reference triangle, we can label the sides. If I know the coordinates of a point on the terminal side, I can label the sides of the reference triangle. And that right triangle, the sides of that right triangle, will be used to create our trigonometric ratios. So let's take a look at our examples here. For cotangent of 840 degrees, let me make a sketch of what that would look like. So 840 degrees, if I go 1 full positive rotation counterclockwise, that's 360 degrees. Another full rotation is 720. And so if I go 90 more, that takes me to 810 degrees, and so I need to go a tiny bit farther to get to 840. So we end up with a terminal side that's in the second quadrant. And to think about the reference triangle, I want to draw a vertical line down to the x-axis. And if you think about that right triangle, because we went 720 degrees, a coterminal angle to 840 would be 120 degrees, which means that the reference angle, the angle created by the terminal side and the closest x-axis, that would be 60 degrees. So let me make a note of that. 60 degrees is the reference angle. And so with that information, we can label the sides. This is going to be a special right triangle, a 30, 60, 90 right triangle. And so if I choose the distance to that point where we dropped a vertical line from the terminal side to be 2, that means along the x-axis we get a length of 1, and the value for y is going to be the square root of 3. Of course, I should make a note that the x value, because we're in the second quadrant, is going to be negative 1, and the y value is going to be positive square root of 3. The label for the 2 would be r. For cotangent, cotangent is equal to the reciprocal of tangent, so we get x over y. And so to answer the question, cotangent of 840 degrees is equal to -1 over the square root of 3. Or rationalizing that denominator, I get the square root of 3 over 3. Example 2 is similar, except here I want to sketch and think about a -315 degree angle. And so I'm going to go in a negative direction, a negative rotation. 315 degrees takes us past the negative y-axis, past the negative x-axis. The positive y-axis would be 270 degrees, so we go 45 degrees beyond that. And we end up square in the middle of quadrant 1, which means that if we sketch a reference triangle here, the reference angle is 45 degrees. Again, the reference angle is the angle between the terminal side and the closest x-axis, the closest part of the x-axis. So let me make a note of that. 45 degrees equals the reference angle. And we have a special right triangle here, 45, 45, 90. So if I label the side lengths, I know that the x and y values have to be the same, and because we're in the first quadrant, those are both going to be positive. The value for r, which is always positive, is going to be the square root of 2. And so we end up with a cosine value for -315. The cosine value is going to equal the x value over the r value. Cosine equals x over r. And so we get 1 over the square root of 2. Or if we want to rationalize the denominator, we end up with the square root of 2 over 2.